Hi guys. I'm gonna do this notes session on how to calculate for pH and pOH, as well as calculating hydrogen ion and hydroxide ion concentrations and a whole slew of other stuff. So be prepared. So first of all, to define for you what the heck is pH and why do we care? You've probably heard of pH before, to be perfectly honest. That's how we refer to how strong or weak an acid is. pH of a solution is the negative logarithm of the hydrogen ion concentration. So again, don't get lost in that terminology, as I've said a million times before. Negative log is just a way to look at certain numbers. So if you know how much of the hydrogen ion is in a particular solution, you know how strong that particular acid or base is. And pH is just another way to look at that number to make it a little bit easier to swallow. So if you want a pH, all you have to do is you have to take the negative log of whatever concentration of hydrogen ions you may or may not have, and you get that number. So the pH scale ranges from 1 to 14. Any pH that is less than 7 is an acid. And the lower the pH, the stronger the acid. So if you have an acid that's a pH of 1 versus an acid that's a pH of 6, the acid that's a pH of 1 is going to be much, much stronger than the acid that's a pH of 6 because it has more hydrogen ions in it. If, however, the pH of that acid is greater than 7, it is a base. If you have a very, very high pH, meaning like 13, 14, that's a very strong base, meaning it does not have a high concentration of hydrogen ions in it. It has a higher concentration of hydroxide ions in it. So this is a visual representation of the pH scale. You have your most acidic substances here on the left, hydrochloric acid being the stomach acid that we all have in our stomachs right now. Lemon juice, apples, bananas, tomatoes, vinegar, all of those things are acidic. You may not have thought of bananas as acidic before, but they most certainly are. Milk is even a little bit on the acid side. Water, generally, is pure water. This is not water with any ions dissolved in it. This is pure water that is completely neutral. If you have things dissolved in it, like polyatomic ions, regular ions, whatever, then it becomes either slightly acidic or slightly basic. But water itself, in its purest form, is neutral. On the basic side, you have blood, baking soda, soap, ammonia, drain cleaner, other things like that. Yes, your blood is just the slightest bit basic. Your body needs that to be able to perform some of its most basic functions. Some of the chemical reactions that go on need that to work properly. All right. So if we're going to find the pH from these hydrogen concentrations, all that you need to do is you need to take this number and take a scientific calculator, and you are literally going to type in negative log parenthesis and put in this number. So what I got when I put that into my calculators, I got this one was a pH of about 2. For B, when I put that into my calculator, I got that one had a pH of 5.52 approximately, and C had a pH of 2.26 approximately. Once again, you are going to type in negative, press the log key, open a parenthesis, type in this number, close your parenthesis, and hit enter. That's it. That will give you the pH of this particular acid. We have pOH, though, on the other hand, and pOH isn't something that I expect you to have heard of. Some of you probably have, some of you may not have. That's okay. pOH is a little bit weird to think about, though, because it is the exact opposite of pH. So if you're looking at a pOH scale, you're essentially looking at the pH scale in reverse. So if I calculated the pOH of a base and I got a pOH of less than 7, that means that thing is a base. If I have a low pOH, I have a strong base. If I have a pOH that's greater than 7, I have an acid, which is the exact opposite of what the pH scale is. On the pH scale, if you have a pH greater than 7, you have a base. But on the pOH scale, if you have a pOH that is less than 7, you have an acid. So you're going to have to think about that opposite as you would the pH scale. And it can trip you up a little bit because most of you are used to the pH scale and you've either never heard of or never really closely looked at the pOH scale. So I highly recommend searching up a graphic of the pOH scale and just taking a look at it if it's confusing you. Preferably one that compares the pH to the pOH scale. So to try some of these, finding the pOH for the following hydroxide concentrations, your keyword here is hydroxide. It is the exact same calculator format that you would use to find the pH of something. It's just that this is the pOH. So you're still going to type in negative log, put in this number, and hit enter. For this one, negative log, put in this number, and hit enter. What I got for letter A was I got a pOH of 6 for letter A, and I got a pOH of 4.48 for letter B. So if you're struggling with that, either look up how to plug that into a calculator on YouTube. I'm sure there's a YouTube tutorial out there, or you're gonna have to figure it out because it's one of the simpler plugins that I can have you do. And unfortunately, I'm not looking at your calculator to figure it out what you're doing wrong if you are doing it wrong. So look it up if you can't figure it out. pOH and pH are directly related to one another in the sense that pH plus pOH equals 14. So if I wanted to find the pH of the solution with this particular, if I wanted to find the pH of a solution with this hydroxide concentration, I'm going to have to go through a couple of steps because doing the negative log of this number is not going to give me pH, it's going to give me pOH. But all I need to do is take my pOH that I get and then subtract whatever number that is from 14, and that will give me the pH. So I'm going to do an annotate real quick so we can figure that out. This number right here, once again, you plug that into your calculator, and I'm going to do that right now. So we're going to type in negative log, and then I usually like to plug in my numbers as a raw number rather than saying 8.2 times 10 to the negative 6 because it's easier for me, but if you can still type that in as scientific notation on a scientific calculator, and that should work. So for me, I'm going to plug in 0.0000082, and then close my parenthesis. And that gives me a pOH of 5.09. So let's write that. pOH equals 5.09. And that is rounded. Yes, it is okay to round. As usual, I expect you to round to 2 decimal places, if at all possible. So then we use this formula right up here, and we go pH plus our 5.09 equals 14. And that is messy, and I'm sorry about that, but pH plus 5.09 equals 14. So we take our 14, subtract 5.09 from that, and we get a pH equaling to 8.91. And so what you should glean from this problem is Well, first of all, here's your pH, and that's what the problem asks for. But if I had asked you to go a step further and figure out if it was an acid or a base, well, you should be able to tell me, just even based on the pOH being less than 7, that it's a base. But if the pOH confuses you, you can always go to pH and see that it's above 7, and you still have a base. So that's good. Let me go ahead and erase this stuff so that we can move on to the next set of slides. Right? So now I'm asking you, what if you're given the pH and I want you to find the concentration of the hydrogen ions in that? Well, in that case, instead of typing in negative log, you're going to take the pH and you're going to plug in 10 caret, open a parenthesis, negative whatever the pH is, close your parenthesis, and hit enter. So these two problems right here, let me open the draw function again. This one wants to know what's the H plus concentration if the pH is 8.9. So what you're going to plug into your calculator, and I'm going to try to write this out as you would plug it in. You're going to go 10, use your caret key, open a parenthesis, type in negative 8.9, close your parenthesis, and then after all this is done, you're going to hit enter, which is basically your equal sign. And then you should, let's see, let me type that in really quickly. So what I get for that is 0.00000001. So that is essentially 1.0 times 10 to the negative 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the negative 9th. So this is what I get. And that is our pH. And that's just a simple calculator function. Now, a couple of you I know have struggled through this class with scientific notation, how to do it, how to convert into and out of it, how to use it. If you are still confused, I am not in front of you, so I can't directly help you with it. So if you're still confused by scientific notation, be proactive. Look up a video on YouTube on how to do it, how to work with it, whatever. Look up an article, look up something. Don't just sit there and be confused by it. Help yourself. Now, for this problem number 2, what about if the pH is 2.3? Well, you're still going to do the same thing. You're going to go 10 caret, open your parenthesis, negative 2.3, close your parenthesis, hit enter, and I'm going to do that myself on my calculator real quick. And that, what I get is 0.005. You can round that to 0.01, or you can leave that as 0.005. Either way, it's fine with me. Personally, if I were given the choice here, I would leave this as 0.005 because on the calculator it reads 0.00501. And so it's a little bit misrepresentative of what concentration you actually have if you do round all the way up to 0.01. So I would just leave it like this. Or you could also write it as 5.0 times 10 to the negative 3. So either way, that's fine with me. Moving on, let me go ahead and erase all this. Okay. How do H plus and OH minus relate? How do those concentrations relate to one another? So those two things relate to one another just like pH and pOH relate to one another, except in this case, it's their multiplied product that is going to be related instead of their summed total. So if you are given one of these and I ask you to figure out the other one directly, you don't actually have to go through the H plus concentration to pH to pOH to OH minus, all you have to do is you have to take whatever H plus concentration I gave you, divide 1.0 times 10 to the negative 14 by that concentration, and that will give you the OH concentration, or vice versa if I gave you an OH and wanted the H plus. This here is a cheat sheet for you. I have two of them actually. I either have this one here or I have this one. My personal preference is this one simply because it's color coded, but if you liked the other one better, if you thought this one was more simplistic, you're welcome to use that one, but I'm going to use this to explain really quickly. So let me open my annotate function once again, and then I'm going to make that this color. It's kind of bright. Okay. So, whoops, my annotate draw. So here on the left, we have pH and H plus relating to one another. And I'm sorry that this is in the way. I can't move it. Maybe I can. No, I can't, apparently. That's annoying. Let me try that again. Nope, it still pops up in the same area. That's really irritating. Oh well, we'll get around it. So on the side, we have how H plus and pH are related to one another. So we have H plus is 10 to the negative pH. So if I wanted an H plus concentration, you would take the pH 10 to the negative pH and it would give you that. If you wanted to go the other way, if I gave you an H plus concentration and wanted pH, you would negative log that H plus concentration. If I gave you a pH and wanted, pOH, all you would have to do is pOH equals 14 minus your pH number. On the bottom here, if I wanted pH, 14 minus the pOH number. On this right side, for how OH and pOH are related to one another, well, it's the exact same thing as here. It's just that we're determining pOH instead of pH. So if I wanted an OH concentration, 10 to the negative pOH. If I wanted pOH and I gave you an OH concentration, negative log that OH concentration and you'll be fine. H plus and OH minus up here. If I want an OH concentration, you take 1 times 10 to the negative 14, divide it by that H plus concentration, it'll give you that. If I wanted an H plus concentration, 1 times 10 to the negative 14 divided by your OH concentration, and it will give you that. So I highly recommend printing this out for yourself if you don't already have it, or at least having a screenshot on your phone or something, because this is invaluable for determining what you need to do and when if you can't remember, because I did just throw a lot of information at you and a lot of calculations. So I'm hoping that that was helpful for you guys. I will continue to post videos as I go. Email me if you have any questions whatsoever. Stay safe. Have a nice day.